Hi, I'm Lorenzo Pellis, and this is EPID2021, a model of COVID-19 spread with a detailed description of within-hospital progression. This model has been developed to support the UK pandemic response, and it has been developed at pace in just a couple of days at the beginning of April 2020, just after the first UK lockdown. And it has been used throughout the pandemic to generate short-term forecasts of hospital burden and real-time estimates of the effective reproduction number to help the UK government monitor the progression of the pandemic. The model is shown here fitted to the first and second wave in the UK, only up to the end of 2020, so that we can ignore complexities like variants and vaccination. But an extended version of this model is still run weekly nowadays. The model uses individual level patient data to choose the best compartments in hospital and estimate the rates of transition between them. And it's then fitted to time series data, as shown here, to estimate the probabilities of following each possible pathway through hospitals. One of the key outcomes is the estimation that the probability of dying both in and outside of ICU has dropped considerably between the first and the second wave. One of the quirks of this model that is worth mentioning, because it sets it aside from other similar compartmental models, comes from an idea originally suggested by Katrina Lithgow, one of the co-authors, that consists of using compartments not only to describe the state of an individual, but also the state the individual will progress to. So, for example, rather than having one compartment for those in hospital, we have one for those in hospital that will proceed to ICU or critical care, those that will die without ICU, and those that will recover. Compared to more standard competing hazards-based models, this model is slightly more complex because it has more parameters, but it's more flexible and it's more directly parameterized with available data. Because we know, for example, it takes only a couple of days to progress to ICU, and instead it takes about a week to recover and 10 or more days on average to die without ICU. Another characteristic of this model that is worth mentioning is its simplicity and transparency. I found that particularly helpful because paradoxically, it was more informative to have the model not fitting the data particularly well, because this would reveal some changes in the system dynamics that it was worth unraveling further. For example, a change in the length of stay in hospital due to a change in the age distribution of admissions. A more complex model would have probably fitted better, but at the risk of hiding such a change in the system rather than revealing it. So the model has many limitations. First of all, the lack of an age structure, but this makes the model more agile and fast to run, conceptually simple, and maximally informed by data, with as few unidentifiability issues as possible. Thank you very much.